Hi everyone, this is the third and final video on continuity with piecewise functions for Math 1451 at Texas Tech University. So in our first video, we talked about just kind of general continuity and translating a graphical idea of continuity to an analytical idea of continuity. And in the second video, we looked at an example where we were finding where a function was continuous. So in this last video, we're going to look at another piecewise function. And we're going to, instead of determining where the function is continuous, determine a specific value of a that makes a function continuous. So we have an a here, and this a is going to be a variable that defines part of our piecewise function. So we want to find how can we define this function so that it is continuous. So we can see that the two functions that define our piecewise, x cubed and ax squared, are both polynomial functions. So that means that we don't have to worry about when those functions are continuous. We just need to worry about continuity whenever we change between them, which is at x equals 2. So just like our former example, we have three things we need to check with continuity. We need to check that the function is defined at that point, the limit exists in that point, and that those two things are the same. So first off, we're going to evaluate the function at 2. So we are going to have f of 2, and then we just use when x equals 2, our function is defined to be x cubed. So this is going to be 2 cubed, which is 8, and there's nothing wrong with that. That is defined. So next, we're going to verify that the limit exists. So because our function is defined differently when we're greater than and less than 2, we're going to take the left-hand limit of the function and the right-hand limit of the function and verify that those are the same. So first, we are going to take the left-hand limit. So we're going to take the limit as x goes to 2 from the left, because the left is less than 2, of f of x. And then to do this, we're just going to take the limit as x goes to 2, and then we're going to put in how f is defined to the left of 2, and that's going to be x cubed. Okay, so then we're just going to evaluate this as 2 cubed, which is 8, and our left-hand limit is 8. Okay, next, we're going to take the right-hand limit. So we're going to take the limit as x goes to 2 plus of f of x. And again, to do this, we're just going to plug in how f is defined to the right of 2 when x is bigger than 2, and that's defined as ax squared. So again, because this is a polynomial, we just are going to plug in our limit point, that 2, in for x. So this is going to be a times 2 squared, which is going to be 4a. And again, this exists, but now we need to verify that those are the same. So this is where the solving for a part comes in. So for these limits to be equal, we must have that a equals 4a, or equivalently dividing by 4, 2 equals a. So for these limits to be equal, we must have a equals 2, and that will also, so that's what's going to make our limit exist. So that's all we needed there. So our last step is verifying that our function value and our limit value are the same. So from steps 1 and 2 above, we can see that our function value equals our limit value, specifically when a equals 2. So since all three conditions are satisfied when a equals 2, this is our answer. A equals 2. Okay. So this is an example of a question where we may have to determine values that make a function continuous. So oftentimes in these questions, we're only going to have one part of our piecewise. It's going to have a in it. And this is just going to come down to taking the left-hand limit and the right-hand limit and making sure that they're the same. So it's going to give us an equation to solve to make sure that these are the same. Okay, so this is about continuity of piecewise functions. So